You guys missed Trig so much.
Emiliano sent you a chat.
And it's so close to your... What?
Nothing.
Melissa! Who are you talking to?
Emiliano.
Who is Emiliano?
The Texas friend.
His name is Emiliano?
Yes, not the one that you know.
I have 0.5 on, so you can just see Jackie in the corner.
Okay, can you put the phone down? You're not like
Here,
actually
put
video shooting. This is not your job.
Oh, no, it's for
Put it. Bend
for
it
David.
like this.
Okay,
Oh.
we gotta get going. Remember identities. Shame on you, my Trig students.
We're not trig students.
Yeah, I'm gonna go change your grade then.
Oh.
Because you know the face that Natalie made? I could see her face. Okay.
Miss, I remember. I just not my favorite. I'm remembering one specific homework thing that almost.
Okay, we will be using two identities for sure. The Pythagorean identities.
That's perfect. Oh, wow. Yo, I should be like a videographer or something.
And a double angle identity.
No, not that. Wait, guys, I have my cheat sheet. I still have it.
Who?
Okay, what are the Pythagorean identities?
There's. Yep.
That one. And the other one, tangent one. Okay. Hold on. Let me see if we need to. Actually, yeah, we need to address this too. And then the double angle identity for cosine, not for sine.
Cosine plus minus 1.
Cosine A, cosine B, plus minus cosine.
Can
no,
someone
sine.
tell me the double angle identity for cosine? There are three of them, actually. Cosine of 2x equals...
Oh, I was doing the sum and difference. Cosine squared theta minus sine squared theta.
Yeah, we are not going to use that one. The other one.
2 cosine squared theta minus 1.
And
1 minus 2 sine squared theta. For x.
we will be using these. On the side of your notes, can you please, I know it's already there. This, like I said, this is, I mix and match materials. This is from, if you see C. Barrel, that's Judah Barrel. He is a CCA math department chair. I used this because this is not on flipped math. Flipped math only has calculus BC topics. The trig integrals and the trig substitutions are not there. But I still have to teach you this. Okay, now this identity, if you look at your notes on the rectangle box, this is actually manipulated into a different way. That is why you're seeing the cosine squared x is being solved for, like this identity. So when you bring the 1 on the other side, you will have 2 cosine squared x. Are you guys following what I'm doing? Okay. And then divide by 2, that's where the half is coming from. It's just from this identity. So cosine squared x equals half of 1 plus cosine of 2x. Okay? And then from here, you're solving for sine squared x. I'm solving for cosine squared x from that double angle identity.
Okay.
Okay. Here, same idea. I'm solving for sine squared x. I will tell you why we need to. When we do the problems, you will understand why we need these. Okay. This is negative 2 sine squared x, so I'm gonna put that on the other side, and then take this on this side. And then, so sine squared x will be half of 1 minus cosine 2x.
Mm-hmm.
It's just manipulating the double angle identities for cosine. Okay. When we have integration by parts, we usually have two different functions, not necessarily the same function. If you look at your integration by parts, we have a polynomial function with the log function, exponential function with trig function. In that case, integration by parts is a good technique to use. But when we have only trig functions, integration by parts will not work, because it's like running around in circle, right? Because the derivative of sine is cosine, and derivative of cosine is sine.
Mm-hmm.
And antiderivative of sine is cosine, antiderivative of cosine is sine. So we can't do integration by parts. It will be like running around in the same circle, and we will never be able to actually solve the integration. So when we have powers of integral, meaning you have sine x, cosine x, or sine squared x and cosine squared x, when we have more than one as the exponent, then we have to use this method. This is trig integrals. Today and tomorrow we'll only be working with trig integrals. Okay. One example. Example 1 is given to you. So if you look at the second rectangle box, it gives you a kind of a general form of how we're going to use the trig integrals. Okay. So there are 3 cases that we will be looking for. The exponent of sine and exponent of cosine. All these 3 cases are based on the exponent of sine and exponent of cosine. If n is odd, if you look at that first bullet point, if n is odd, meaning if the exponent of sine is odd, then we're going to factor out 1 sine x, and then we're going to use the Pythagorean identity.
I'm just making sure David sees.
When we do you don't have to memorize these, because when we do the problems, you will automatically, the more you do, you will understand, oh yeah, if I factor out the sine, it will be easier to use the Pythagorean identity. But if the exponent of cosine is odd, then we will use the other identity, which is in terms of cosine squared x. Okay. If both are even, then we're going to use a double angle identity. That is one thing that you have to remember, is both the exponents, sine and cosine, are even exponents. Then we will use a double angle identity in the re-manipulated form. Okay?
All right.
Okay. Let's have fun!
Spaced out.
Huh?
Okay.
I spaced out.
That is why I do examples, so when you space out, no mistakes. That's what happens when you space out in calculus. By the time you come back to Earth, the entire lesson will be done.
Okay.
Okay. Okay, which exponent is odd?
Cosine.
Cosine's exponent is odd. So in our rectangle box, which case are we looking at?
Excuse me. The second one.
The second one. Okay, we're gonna follow the
Wait, the
directions
second one?
in the second one. That's case number 2. If m is odd, which means the exponent of cosine is odd, we're gonna factor out 1 cosine from here.
Mm-hmm.
And then we're gonna use the identity. Okay, this is what I'm gonna do it step by step, okay? And eventually we can get rid of the steps and do it at What does factoring out 1 cosine mean? I'm gonna factor in yellow and write everything else in white. So we have sine squared x, and the cosine, only 1 cosine is going to be factored out, so which is yellow. Okay? And then what is left?
Cosine squared.
Cosine squared x. Okay. Right now, the goal is to to have everything in one function. That's the goal. Okay? Now, what we could do is substitute. We're going to do u sub here, by the way. And then we're going to rewrite our cosine squared x. It says factor out 1 cosine x, use the identity cosine squared x equals sine squared 1 minus sine squared x. Where is that 1 minus sine squared x coming from? What identity is that? The Pythagorean identity.
Yep.
Right in your, maybe we should have here, the Pythagorean identity.
Equals 1.
We can rewrite our cosine squared x equals 1 minus sine squared x. Yeah, that's where this is coming from. Okay, the factored out cosine x is going to be in white now. And this part I'm rewriting as 1 minus sine squared x.
Okay.
Oh. Now I see.
Oh my gosh. These pants,
I understand it now.
are giving me chills.
Oh, I thought you had to use the bathroom.
No, like every time these beads like touch my skin, it's cold.
Oh,
Why did you wear them?
I don't know.
bro, the
Because I
camera
like
tracking
these
is elite.
things.
Oh my goodness.
It's comfortable.
Okay.
Okay. Now we're gonna do u sub.
Okay.
We are going to substitute for what? How do we use u sub?
Whatever's in the parentheses.
No, no,
Oh.
not always.
Whatever is easy to integrate. Now, if I do u sub for cosine, what would be the derivative of cosine?
Negative sign.
No, yeah, negative sign. But I can't substitute du squared or any of those. It's hard to do that. So I'm going to pick the harder one as my u. So u is going to be sine x.
Okay.
Because then I can replace the sine x, sine squared as u squared, sine squared as u squared, right? That is the whole point. Because if you did it the other way around, it won't work. Okay, so now du would be
Cosine. Negative cosine.
No,
Cosine.
cosine.
Positive cosine x dx. See how I can now replace this chunk that I factored as du.
Mhm.
Okay? Because if you did it the other way, you can try it. If you did it the other way, it won't work. Okay, so now I'm gonna replace sine squared and this sine squared
With u
with u,
squared.
u squared. So this is u squared times 1 minus u squared, and the one that I boxed is going to be du.
That kind of looks like inverse.
No, this is just simple. Yeah, it's just simple integration. This becomes like a little simple integration, that's all. Okay. Oh gosh, I can still smell the refreshment. Okay, now if you want, you can multiply it out and then, make it a little bit better. So this would be u squared minus u to the 4 du. And now you're doing the antiderivative of all of these. So that is u cubed over 3 minus u to the 5th over 5 plus c. Make sure now replace the u with the original function that we have, which is sine x. So our answer is going to be sine cubed x over 3. Make sure you put the x minus sine to the 5th power plus c. This is our answer.
That's actually not power.
I know.
I understood
Let's
that.
not jinx it.
Oh yeah. Next example is gonna be bad. She's smiling. Yeah. Okay. Is it bad, guys? I don't know. Either way, I wish all of us luck.
Garden size is crazy.
try now is going to be your practice. Okay, I'm gonna now do the example 2.
Try now. What?
It's gonna be a test.
Try now will be your practice.
This one.
That's
the top
because
one?
with your King Super's card, this is the same price as the small deck. So I thought we may as well.
What is he saying?
I don't know.
She said
No,
that the
he's talking
party
to
size
himself.
was crazy, and he tried to explain why he gets the party size because with the King Super's card, it's basically the same price as the smaller one.
What she said.
Aaron Perales Longoria, you are on high honor roll. You're so high that people cannot reach you. Leslie Aceves Padilla, you are also on high honor roll. Daniel Giramaria, high honor roll. I don't know what that is. Like, what do you mean? High.
It means that your GPA is 4.
Above 4.0.
Yeah.
Whew.
You have a very sensitive nose.
I cannot handle smells because it makes me sneeze. Okay. Example 2.
Not this one. Oh, what's the crayon? Okay.
We have sine cubed x.
Oh, he'll punch this and put it in.
Okay. So the idea is if something is odd, that is the one that we are factoring out. Right? In the previous example, cosine was odd, we factored out one cosine. So here, which one is odd?
A sign.
Sine is odd, so we're going to factor what?
A sign.
A sine. See? I'm telling you. When you do it, it will make sense. Okay, now we're going to replace the sine squared with what?
1 minus cosine.
1 minus cosine squared x. Okay, then we're going to do the u sub for
For cosine.
Cosine. Yep.
See, you guys are so good at this. You can take the test tomorrow.
What?
No.
What's the derivative of cosine?
Negative sign.
Yep. The negative is not going to be a problem. It's just going to come out of the integral and stay there.
Yes.
So I'm going to put the negative here. Integral sine x dx is replaced. The box is replaced with du. And then cosine x is getting replaced with u. All the cosines
So-
with the exponent will be replaced with u.
Sine x is du.
Yeah.
Okay.
Okay, so now before you find the antiderivative, make sure it's all like simplified and nicely laid out. So u to
That'll
the
work.
4th minus u to the 6th du, and then the antiderivative would be, make sure you put square bracket because the negative is for everything that comes out of the integral. So put a square bracket. U to the 5 over 5 minus u to the 7 over 7 plus c. And now I'm getting ready to multiply the negative, so u to the 5 over 5 plus u to the 7 over 7 plus c. And what did we substitute for cosine x? So cosine to the 5x over 5, cosine to the 7th over 7 plus c. going to let you struggle with for trying out too. Okay, example 3. What kind of integral is it?
They're definite.
Definite integral. Remember, you can do integration techniques for all kinds. It's either definite or indefinite. This is indefinite. Now we're going to find the definite. When you do the definite integral, you're expecting a numerical answer.
Yes.
Okay.
Find
Also, you did trig functions a little bit in Calc 1. With did you how to find like derivative of trig functions like with bounds or like at theta equals whatever, and you use whatever thingy on the calculator. When we do trig in calculus, we always work with radians. We do not ever work with degrees. Okay.
That is so sour.
Example 3.
And that is why you memorize the unit circle, guys.
What? It's lemonade with pomegranate juice.
Sebastian feels very left out for a random reason.
It's okay, so that's,
Oh, we have even powers.
yeah.
So what identity are we gonna have to prepare to use? The double angle identity.
And yeah.
So we have to change both, actually.
Yep.
Okay, so starting with sine squared x. What is the double reversion of the sine squared x?
1/2 of 1 minus cosine 2x.
Okay.
Stop.
Is it okay if I put that, or do you
No.
want me to put the 1/2? I mean, I'm still the same.
Negative
1/2
1/2
times-
cosine.
And this one would be 1 plus cosine of 2x over 2. Half times 1 plus cosine of 2x is the same as 1 plus cosine of 2x over 2.
Okay,
Yes.
okay, wait.
Okay. I'm waiting or am I going? Are you okay with this understanding? Maria? Okay. No, that yeah doesn't sound convincing to me. This is what you have on the front page.
Oh, so it's the same as
These
just
two
making
are the
all
same
of it.
thing. Multiplying by
over two.
half is the same as dividing the entire thing by 2. Okay.
Party size is crazy.
I thought
Okay,
it was
so
going to
what
be-
I am going to do, I don't know what I did here. I did it like 3 years ago. I don't know what my thought process was here. Let me see what I did here.
Find the integral and then plug it in.
Yeah, I multiplied the numerator and kept the denominator as it is. And then I separated
has a
them.
problem.
Okay, that's what I did.
If I
Okay.
was watching a video to learn and you kept doing that, I'd have pissed.
Multiply the numerator. What will you get when you multiply the numerator?
No, it'll be like a kind of like a quadratic, where it's like the foil.
Okay, yes, it is a quadratic. It will be like quadratic, but I want you to memorize this. I don't know if you memorize this or not. I know I've been telling you since Trig to memorize this. If you haven't, you have to do it right now. Because, again, we don't want to spend our mental energy on small things. If it is in this format, recognize that format.
That's
It's
not
a
what?
squared minus b squared.
Okay.
We are not doing FOIL, we are not doing box method, we are not wasting our mental energy on those small things. When you see the same thing but opposite of these second term, then we are going to use that. So which would be 1 minus cosine squared 2x over
2
times 2.
4. Oh, you're multiplying both of them, right? Okay.
See, that's what I was thinking, but I just didn't want to say it out loud.
dx. Okay. Here's the fun part. I guess.
You guys?
Now your white is stained red because you like red.
Let me.
Jackie's like holding back. Right
Don't
now,
worry. My
because
shirt has a stain.
She's not in the mood today.
Okay, there is no easy way of doing this either. However method that I choose, it's still going to be complicated. I'm just going to stick with the complication method that I did 3 years ago. I'm going to separate the terms now. We can easily separate them because it's 1 over 4
Yep.
dx, okay? That integral is there, minus integral 0 to pi over 2, cosine squared 2x over 4 dx. The reason why I separate them is because this one can be easily solved. I don't have to worry about it. But this is another trig function with an exponent.
So
So what do we do?
you said no.
If you do u sub, then you will have a sign that we don't want to deal with.
But Loki?
When you had,
Just put x at the end of it.
huh?
Can you just put x at the end of it? Because there is, like, to find the energy of the one.
This one.
Oh, that, no.
We can deal with this. We know how to do that. This one. Okay. This is what we're gonna do. I'm gonna do this minus 1/4. I'm gonna bring it out of this integral. Okay. This can be rewritten just like how we did our cosine squared x. What was cosine squared x? The doubling identity for cosine squared x.
Minus sin.
Huh?
I don't know.
Go back and look. Cosine squared x equals what?
1 minus.
1 plus cosine 2x over 2. Right?
Bless you.
Hello? Are
Bless
you okay?
Thank you. Yeah.
You okay? Okay. Look, when you have an exponent other than 1, you have to somehow figure out to rewrite it in a different form. Okay? So this is what we have. The only difference between this and this is the angle is just 2x, that's all. So I can use the same idea of this to rewrite that in a doubling identity. So cosine squared of 2x will be 1 plus cosine of 4x over 2.
The handwriting's legible, right?
Yeah.
Sebastian.
I actually got a compliment on it. Like, it's
Sebastian.
actually getting better.
I thought that, would that cancel out the 2 on the denominator?
That will just still be there because it's a number. The
So we're
only
just-
thing that is getting, so whatever this angle is, this angle is getting doubled here. So if it was an x, it'll be a 2x. If this was a 2x, it'll be a 4x. If it was a 3x, then it will be a 6x, that's all. That's why it's called double angle identity. So the angle is x, regardless of what that is.
Okay.
So this part now can be further rewritten as what we have there. 0 to pi over 2, 1/4 dx.
Okay.
Look what I'm doing. I am not doing multiple things in the same step, because if you start doing that, then you will confuse yourself. Like, I could find the antiderivative here, but I'm not doing it yet because I want to make sure that I'm doing everything at the same step so we are not confusing ourselves. Minus 1/4, I am rewriting cosine squared of 2x as 1 plus cosine 4x over 2 dx. Okay, once we have all single exponent, then we can just do our math. No? I lost you?
I've been lost.
Because you are just looking at your handwriting and not actually paying
No,
attention
I'm actually
to
paying
calculus.
attention to this. But yes, the handwriting is pretty nice to look at.
Is this better when you look at it?
I'm just confused with the 4. But 10. Where did the 4 go?
We could take the 1/4 out if you want, but I
Yeah.
don't think that's gonna
Okay.
actually make
Because
any
it's a double one
changes
So you just
So you just double it, yeah.
to the steps. Shall I continue?
Yes. I understand it now.
as you wish.
Okay, now I am going to actually integrate all of those stuff.
Does your phone have a lot of storage?
Actually, yeah, sure.
Does it have a lot of storage?
Yeah. I've only used 40 something of it.
I know the 2 can come out of the integral, so that makes it 1/8. If you guys are talking, then you're not paying attention.
Thanks. Okay.
More writing? Let's do this.
She says she's continuing. What do you expect?
Yes.
Okay, now what's the antiderivative of dx? X. Okay. I always put square brackets. Anything that comes out of the integral, make sure it's in square bracket because these numbers that are outside the integral need to be multiplied later. Now 0 to pi over 2. Square bracket. That's the first integral. Second integral. Where did this 8 come from?
You made a fraction for
I took the 2 out of the integral. That's why. Because I don't want to deal with numbers anymore.
So what letters? Letters.
That's why the 1/8 is there. I'm going to put the square bracket because I'm getting ready to find the antiderivative of these. What is the antiderivative of 1 dx?
X.
X plus antiderivative of cosine of 4x.
Sine 4. Negative sine 4.
Negative 4 sine?
1/4 sine 4x.
X plus 1.
Okay. 0 to pi over 2.
Oh.
I'm going to let you reflect on that step.
And then we have to do the
Now you're gonna getting ready to plug it in. Wherever I see zeros, I am not concerned about the zeros. So let's worry about the zeros later, okay? I'm gonna plug it in separately for each integral, so I'm not missing the negatives or messing up things anywhere. Okay. 1/4 square bracket, plug in pi over 2, which is pi over 2, minus 0. So I'm just going to leave it like that. Are we good with that?
Mm-hmm.
Close the square bracket. I'm not getting ready to remove anything right now. I'm still keeping everything separate. Minus 1/8 square bracket, pi over 2, plus what is sine of 4 times pi over 2?
Sine of pi over 2 is...
Why is it 0?
Because if you multiply the 4 and then you divide by 2, it'd be 2 pi.
Okay, so sine of 2 pi is 0. Because we are back here, cosine of 2 pi is positive 1, sine of 2 pi is 0. So this whole thing will become 0. I don't have to worry about it.
Okay.
Okay, because I don't want to put extra things if I don't have to worry about it. Okay, now I'm going to subtract the 0, right? This will be 0.
Mm-hmm.
This will also be 0 because sine of 0 is 0. So then I don't actually need any of these fancy stuff. Okay? I'm not putting plus 0 because I don't want to do unnecessary things in here that will confuse you more later. Okay, now just multiply the pi over 2 with the 1/4, which would be?
Pi over 8.
Just do 1/4 minus 1/8 because then
No, it doesn't. I mean, yes, you can, but the pi over 2 will not cancel out. It will still be outside. Like you can factor the pi over 2. It won't cancel out. Because it's a number. You can't cancel out like that. It will be a totally different value when you multiply it. So this will be pi 8ths minus pi 16ths. Pi 8ths minus pi 16ths is... Which one is topic of fraction.
Good.
Which one is actually a larger piece? 1/8 or 1/16?
1/8.
Okay. So you have 1/8 minus 1/16. What do you have?
1/16.
1/16. Because 1/8 is the same as 2/16.
Mm.
So 2 pi over 16 minus pi over 16 is pi over 16. Let's see if I got that. Yep. Bingo.
That was so easy, guys.
You can, with definite integrals, you can check with the calculator. When you check with the calculator, make sure that your calculator is in radian mode,
You look-y ate all the chips.
because my trick students would have switched the mode. So make sure it's in radian mode, and then in the calculator, you can do the math part, and you will get some decimal, and then do your children, I am
Bless you.
telling you how to check your own answers. On the calculator, you do the integration part on the calculator with, make sure it's in radian mode, you should get some decimal answer. And then you put your answer, pi over 16, in the next line and see if those two answers match.
We put the very, very original or
The original one,
the sign, the one.
the sine one. Sine squared x, cosine squared x one.
Nope, not that
Jackie,
one.
bro.
I'm sorry, I haven't eaten breakfast.
Okay,
I had donuts, so I feel you.
when does this class end?
11:14.
11:14. Shoot, I don't think we'll have time.
Time for the fourth exam.
It's equal to 0? Huh?
Mhm.
Oh, you are putting 0. So,
Change the color.
I'm assuming it's in radian mode.
I was talking about
What?
Oh, yeah. Yeah.
We won, as
Yeah.
always.
I think it's in radian mode. Okay, make sure it's in radian mode before you do that.
No, I changed mine to radio.
Oh, okay. Okay, are we ready to move on to the next example, or do you want me to wait until you check your answers, or what?
How do we check that?
Math 9.
Okay, thank you.
And then when you're putting your integral thingy, make sure you have parentheses and everything. Flaming hot, Lay's
Sine
for
squared.
breakfast, McDonald's for lunch.
Could you answer the more important
No.
questions first?
What do you mean no?
How do you make the
5
signs?
liters Coca-Cola for drink.
Miss, you know
How
my
do you
mom,
make
like,
the
she-
sign squared?
Huh?
The sign.
Oh, you have to put parentheses for sine x
Mhm.
and then put the square.
Okay.
You know my mom, she has issues with Coke where like one time, like she won't eat without a Coke. Like one time someone drank her Coke that was in the fridge. And when she sat down to eat, she was like, "Where's my Coke?" She started crying.
No, wrong.
No,
She sent someone out to buy a Coke and she didn't start eating till the Coke was in the house.
Okay, if you're using your calculator to check, and if you don't enter things correctly on the calculator, it gives you a different answer, and your answer is actually correct, and you will panic on the test. Okay,
Log in.
sine x should be sitting inside the parentheses, and then you square it. Or you can put square for, I don't know, maybe this calculators are fancy, so
Never
it will
mind.
take the sine squared as it is, huh? Give me the calculator, let me see.
And instead of Coke, it would be Dr. Pepper.
She started crying.
Oh.
Oh. Danny, you want your phone back? Or is it okay if David still? Miss, someone's at your door.
Is everything okay? Look.
Okay.
Make sure you put,
Another princess.
yeah,
Square.
it's pi over 2, not 2 over pi. Who was at my
I'm gonna go
door?
home and get my water bottle.
Wow, you actually have a water bottle?
Yes, I do. I forgot to bring it this morning. I would have like drank the entire
That's
thing.
my husband. Why can't he open the door? What is happening? He can't open the door?